Hello again, everybody. Welcome back to Beginning Algebra. Today we're in section 6.2, and we're going to be talking about factoring trinomials. So in this section, we'll just be looking at trinomials whose leading coefficient is 1. So I'll show you the basic method that we use to factor trinomials, and then we'll work on factoring trinomials that have a GCF. So it'll kind of be a two-step process. First, we'll factor out the GCF, and then we will factor the remaining trinomial. This is a really important skill, and understanding how to factor trinomials and really being good at it is going to ensure your success in later math courses. So let's go ahead and get started. Now, in the previous section, we learned how to reverse the distributing process. So we learned how to factor out a GCF. In this section, we'll be learning how to reverse the FOIL process. So what we're going to do with each problem is we'll start with a trinomial and we'll reverse the FOIL process so that we end up with a product of two binomials. You'll remember back in chapter 5, we learned how to use the FOIL process to multiply two binomials together, and the result was almost always a trinomial, except under special circumstances. So when we factor, what we're really doing is just reversing that multiplication process. So we take our trinomial and put it back so that it's the product of two binomials. Now keep in mind that not all trinomials can be factored, but if a trinomial can be factored, then it will always factor into two binomials. For example, here is a trinomial. We have x squared plus 5x plus 6. And because this is a trinomial, I know that if it factors, it will factor into two binomials. So I'm going to go ahead and set down two empty pairs of parentheses. And now, remember, it's kind of like we're undoing a process. So if we look at the first term, this x squared had to come from first times first. So it just makes sense that this would have been x times x. So I'll go ahead and write those in. Now when I look at the last term, I can see that multiplying last times last gave us a positive number. Now, the only way to get a positive is to either multiply negative times negative or positive times positive. In other words, if the last term is positive, it means the two signs we have here in our parentheses are both the same. And it turns out they both have to be the same as the sign on the middle term. So this tells me that the two have to be the same. This tells me that since they're the same, they're both positive. And now I notice that last times last made 6. So the numbers that go here and here are either 1 times 6 or 2 times 3. Now I have to choose which pair of numbers to use, but I also need to keep in mind that outer plus inner is going to have to add up to positive 5x. So let's go with 3 and 2. And now you can just check that first times first is x squared. Outer times outer is 2x. Inner times inner is 3x. Together they will add up to 5x. And last times last is 6. So these two binomials are the factored form of this trinomial. Now I'm going to give you the steps that you can use to factor a trinomial, but I don't want you to get all hung up on the steps. We're going to practice with this process enough that it should become second nature to you, but I like for you to have the steps written down so you can refer to them if you need to. So, to factor a trinomial, first we need to verify that there's no GCF. If there is a GCF, we need to factor it out. But make sure that you keep it with your answer. You can't just toss it away like a banana peel. You have to keep it. It's part of the final answer, so don't lose it. And then the second step is to put down two pairs of parentheses like I did in the example on the last screen. And our binomials are going to go in these parentheses. And then you'll want to look at the first term of the trinomial and separate it into two factors and put those in the parentheses. Then you're going to look at the sign of the last term in your trinomial. If the last term in the trinomial is positive, then the signs in the binomials must be the same. And if you decide that the signs need to be the same, then they're going to need to be the same as the middle term of your trinomial. If the last term in the trinomial is negative, then the signs in the binomials are going to have to be different. So you can just put in a plus and a minus. Your next step is to look at the last term of the trinomial and think about the number this time, and separate that number into two factors, and you'll put those factors in the parentheses. Then you'll need to check that outer plus inner will produce the correct middle term. This is not optional. This is not something that we do like checking the solution to an equation to make sure that we didn't make a mistake. This is part of the trial and error process, so this is a necessary step. If the outer plus inner matches the middle term of the trinomial, then we guessed right and we're done. But if the outer plus inner does not match the middle term, then we've still got work to do. If you get the right number that you needed, but it's the wrong sign, all you have to do is change the signs and you're done. If you get the wrong number, then you'll need to erase what you put in for last times last and try two different factors. So we're going to go through several examples together here. This is a skill that you have to learn. It's not really that different from putting together a jigsaw puzzle or working on a Sudoku puzzle, but it's actually a lot simpler than either one of those things. But this is a trial and error process, kind of like you might use in one of those situations. And we're going to use the steps that I just gave you. So if it helps you, refer back to those steps as we go through this process and make sure that the process gets set in your mind really well. And then you want to make sure that you do plenty of practice on your own, because that's really the only way to build up this skill. So here we have a trinomial, m squared plus 9m plus 14. Now remember that if a trinomial can be factored, it always will factor into two binomials. So first, let's just start out by making sure that there's not a GCF. Notice that the first coefficient here is 1. So there's nothing that goes into all three coefficients besides 1. And notice that m is not common to all three of these terms. So there's no GCF here besides 1. That's good. Now for step 2, we know that a trinomial is going to factor into two binomials, so we set down our two pairs of parentheses. And we say, how can we make m squared? First times first is m squared. So what can we put here? So we can put m times m down to get m squared. Now the last term is positive. So that tells me that the signs here in the binomials will both need to be the same. And if they're the same, they're both going to need to be the same as the middle term. So I'm going to have plus and plus here. And now last times last made 14. So my choices for 14 are either 1 times 14 or 2 times 7. You might not feel like you always need to write down your possible choices for last times last, and you really don't. Sometimes it's obvious what the right pair of numbers is, but when there are lots of factors, I think it's a good habit for you to write them all down so you can mark them off as you try them. Alright, so last times last has to be 14, and keep in mind that outer plus inner is going to have to add up to 9m. So I think you probably are already ahead of me, and you can see that if we put the 2 and the 7 in, then we'll get the middle term that we need. So always before you leave a problem, you have to make sure that the middle term is going to add up right. Because remember, we are in control of what we put down for first times first, and we are in control of what we put down for last times last. But the only thing we've not made sure of yet, the only thing we've not nailed down, is that the middle term is going to add up correctly. So let's check our outer plus inner. Outer times outer would be 7m. Inner times inner would be 2m. 7m plus 2m is 9m, and that's the middle term we wanted. And this verifies for me that our factoring is correct, so this factoring is our final answer. Every now and then I'll have a student who will get confused and they think that the checking step is the final answer. But no, remember the instructions said factor, so the factoring is the final answer. Here is a practice problem. You could pause the video and try this one on your own, and I really encourage you to do that. Or now I'm going to go through it with you. So first we want to make sure that there's no GCF other than 1. So certainly since our leading coefficient is 1, nothing's going to go into all 3 coefficients except 1. And notice that y is not common to all 3 terms. So that means that our step 1 is taken care of because there's not a GCF besides 1. Now step 2 says put down our 2 pairs of parentheses, and then step 3 says look at the first term. Now the first term is y squared, so that could be y times y. We'll go ahead and separate our y squared into y times y. And then we look at the sign of the last term, which is positive. So this tells me that the signs in the binomials will need to be the same. And if they are the same, they'll need to both be the same as this sign. So the signs in the binomials are both going to be positive. Now last times last has to make 20. So my choices for 20 are either 1 times 20, 2 times 10, or 4 times 5. And I need to choose a pair of numbers that is going to allow me to get outer plus inner to add up to this middle term. So look at your choices here and see which pair of choices you think will let you get a middle term of 12y. And I think we can all agree that it's probably 2 times 10. So I'll put 2 times 10 in the parentheses. Now it wouldn't matter if you would put the 10 here and the 2 here because you'd have the same 2 factors either way. Now we have to verify that our middle term is going to add up correctly. We know that first times first is going to make y squared. We know that last times last is going to make 20. Those two are not in question. What we have to make sure of is that we got the middle term correct. So let's check the middle term by saying outer times outer is 10y, inner times inner is 2y, 10y plus 2y is 12y. So that verifies for me that we chose the right numbers here and that we're finished. So our final answer is this factoring right here. Now here in example 2 we have a negative middle term. So that's really not going to change much, but let's just go through it together and see what happens. So first, notice that there's no GCF other than 1. Nothing is common to all 3 terms. So we can go ahead and set down our 2 pairs of binomial-sized parentheses. Now we're reversing the FOIL process. So start with the first term. This is x squared. So first times first is going to have to be x squared. We can just put down x times x. Now the last term is positive. So remember that this plus sign tells me the signs in the parentheses are going to need to be the same. If they're the same, they both have to be the same as the middle term. So I'm going to get 2 minus signs in my binomials. Now last times last again is 20. So remember the factors of 20 are either 1 times 20, 2 times 10, or 4 times 5. This time I need outer plus inner to add up to negative 9x. So you probably can tell that if I put the 4 and the 5 in here, in either order, then I can get the negative 9x that I need for the middle term. So let's check the middle term. So outer times outer will be negative 5x. Inner times inner will be negative 4x. Then we add these two together. Negative 5x minus 4x would be negative 9x. That's the middle term we wanted, so that verifies that our factoring is correct. Here's one for you to practice on, so again, pause the video and try this one by yourself. Now let's go through it together. So first I notice that the GCF is 1. There's no factor other than 1 that's common to all 3 terms. So I can go ahead and set down my 2 binomial-sized pairs of parentheses. Now first times first is w squared, so I'm going to have w times w here. The last times last made a positive term, so that tells me that these 2 signs in the parentheses need to be the same, and they both need to be the same as the middle term, so I'll put down 2 minus signs. And then let's make a list of factors for 32. So 32 could either be 1 times 32, or 2 times 16, or 4 times 8. If you keep going, the next pair of factors you'll run into is 8 times 4, and we've already got that covered. So You have to look at your choices here and decide which pair of numbers will help you get the middle term of negative 12w. So we need outer plus inner to be negative 12w, so let's try the 4 and the 8. And now let's just check that middle term. So outer times outer is going to be negative 8w. Inner times inner is going to be negative 4w. Negative 8w minus 4w is negative 12w. That's exactly the middle term that we wanted, and so that verifies for us that this factoring is correct. Here's example 3, and this is our first time looking at a trinomial that has a negative number for the last term. But the same process still works. So we still start by verifying that the GCF is 1. In other words, we verify that we don't have to factor out a GCF. And once we've done that, we can go ahead and set down our 2 empty pairs of parentheses. Now, first times first is going to be x times x, as usual. The last term is negative, so that's telling me that the signs in the parentheses here will have to be different. So in this case, it doesn't matter what sign the middle term has right now. We'll have to set down a plus and a minus in our binomials. Now, last times last made 6. So these numbers here either had to be 1 times 6 or 2 times 3. Now this time, because the signs are different, it will matter which order we set the numbers down in. If we want the middle term to add up to a positive number, then we should put the larger number with the positive sign. So I'm going to put the 3 here and the 2 here. And now let's just check our middle term. So we'll say outer times outer is negative 2x. Inner times inner is positive 3x. Negative 2x plus 3x is positive 1x, which is exactly what we wanted for the middle term. So that verifies for us that this factoring is correct. Here are a couple of similar exercises that you can pause the video and try on your own. Now, if you've done that, I'm going to go through these with you. So in part A, we have z squared plus z minus 30. And notice that the only factor common to all 3 terms is a 1. So we really don't have a GCF to factor out. Let's go ahead and set down our 2 empty pairs of parentheses. First times first is z squared, so we're going to have z times z. And you might be wondering why my z's look a little different. So whenever I write them by hand, I put that little mark there so that they don't look like 2's to anybody. So these are z's. And then the last term in our trinomial is negative, so that tells me I'm going to have a plus and a minus in my binomials. Now we need to put down factors that will make 30. So let's make a list of factors that will produce a 30. 1 times 30, 2 times 15, 3 times 10, and 5 times 6. See, when you have several pairs of factors, it does help to have them written down because it's so easy when you're doing everything in your head to forget about one of the pairs, and that might be just the pair you need. So it kind of does help to make a habit of writing down those pairs of factors. Now, we need outer plus inner to add up to positive 1z. Remember, outer and inner are opposite signs. So don't think about looking through this list looking for a pair of numbers that will add up to 1. It's really best if you'll just pick a pair of numbers and put them in the parentheses and see if they add up correctly. So I'm going to choose the pair 5 times 6. And since I want the middle term to be positive, I'm going to put the larger number with the positive sign. And so now let's check our middle term. Outer times outer would be negative 5z. Inner times inner would be positive 6z. Those two are going to add up to positive 1z. That's what we wanted for our middle term. So that verifies for us that this factoring is correct. And on part B, again, the GCF is 1. So we can start with our 2 empty pairs of parentheses. First times first needs to be x times x. Because the last term is negative, we know that we're going to need a plus and a minus in the parentheses. And now last times last is 24. So what pairs of factors will give us 24? Our choices are 1 times 24, 2 times 12, 3 times 8, or 4 times 6. And remember, these are different signs and we need the middle term to add up to positive 2x. So I'm going to choose 6 times 4 from this list, and I'm going to put the 6 with the positive sign so that the middle term will add up positive. So positive 6 and negative 4. And now let's check our middle term. Outer times outer is negative 4x. Inner times inner is positive 6x. Together, those add up to positive 2x, which is what we wanted, and so this factoring is correct. So here's example 4, and this one's going to be p squared minus 2p minus 15. So this is just another trinomial, and it still uses the same procedure that we've been using all along. So we notice that the GCF is 1. So we'll go ahead and set down our 2 empty pairs of parentheses. And first times first is p squared. That's going to need to be p times p. Last times last made a negative number. That tells me that the signs here in the binomials will need to be different. And my choices for 15 are either 1 times 15 or 3 times 5. Now remember, these are opposite signs, and we want the middle term to add up to negative 2p. So this time we're going to need to put our larger number with the minus sign. So let's choose the factors 3 times 5, and I'm going to put the 5 with the minus sign and the 3 with the plus sign. And now let's check outer plus inner. Outer times outer would be negative 5p. Inner times inner would be positive 3p. That's going to add up to negative 2p, and that's what we wanted here. And so this factoring is correct. Here is a practice one that you can try on your own. So again, pause the video and try it yourself. Now let's do it together. So notice that the GCF is 1, and we can go ahead and set down our 2 empty pairs of parentheses. The first term is r squared, so first times first is going to need to be r times r. The last term is negative, so that tells me the signs here in the parentheses are different. And then last times last has to make 16. So my choices of factors are either 1 times 16, 2 times 8, or 4 times 4. And we need to choose a pair of numbers that's going to allow outer plus inner to add up to negative 6r. So let's go with 2 and 8. And remember, because we want the middle term to be negative, we'll need to put the larger number with the negative sign. So we'll put the 8 here and the 2 here. And now let's check the middle term just to make sure that we made the right choice. Outer times outer is negative 8r. Inner times inner is positive 2r. Those two are going to add up to negative 6r, which is what we needed, and so this factoring is correct. Now remember that if a trinomial can be factored, it will always factor into 2 binomials. However, not all trinomials can be factored. A trinomial that cannot be factored at all is called prime. Prime just means not factorable. So let's look at example 5 and we'll see if these 2 trinomials are factorable. So on part A we have x squared minus 5x plus 12. Notice first that the GCF is 1, so we can go ahead and set down our 2 empty pairs of parentheses. First times first is x squared, so that's going to make us put x times x here. The last term is positive, so this tells me that the signs in the binomials must be the same. And if they're the same, they must be the same as the middle term. So I'm going to need 2 minus signs here, and that is not negotiable. So that's got to be that way. Now, the only thing we have a choice about is last times last. So here we have 12, and our choices for 12 are either 1 times 12, 2 times 6, or 3 times 4. So let's just start by putting 3 times 4 in the parentheses and see if we can get this middle term that we need. So if I put the 3 and the 4 in, outer times outer is negative 4x, inner times inner is negative 3x. Now negative 4x plus negative 3x adds up to negative 7x. That is not the middle term that I needed. So I'm going to erase those 2 numbers. And now let's try 2 times 6. If we have 2 times 6 in there, then outer times outer will be negative 6x. Inner times inner will be negative 2x. Negative 6x plus negative 2x is going to add up to negative 8x. Again, that's not the middle term that we need. So these are not correct. So now our only remaining choice is to try 1 times 12. And you can see here that if I add up outer plus inner, again, I'm not going to get negative 5x. I'm going to get negative 13x. So now I've tried every available choice for 12, and there's really nothing else we can change. So we've now tried every option available to us and none of them work. So that tells us that this trinomial cannot be factored, and that means this trinomial must be prime. Let's try the same thing on part B. Here we have k squared minus 8k plus 11. So there's not a GCF except for 1. We'll go ahead and set down our 2 empty pairs of parentheses. And now we'll say first times first is k squared. That's got to be k times k. The last term is positive. That tells me that these signs will need to be the same. And they're both therefore going to have to be negative. Now last times last has to make 11. And since 11 is prime, our only possible pair of factors here is 1 times 11. And if we try the middle term, outer plus inner is going to add up to negative 11k plus negative 1k, which is negative 12k. And that's not a match for our middle term. So I know that these factors are not correct, but there are no other factors available for us to try. And so we can just say that this trinomial is prime. Now, it's possible for a trinomial to have 2 variables in it. That doesn't make the problem harder. That just means that both terms in your binomials will contain variables. Nothing else changes, so the same strategy still works. Our process is not going to change at all. So here's an example where we have 2 variables. We have q squared minus 2qm minus 3m squared. Notice that nothing except 1 is common to all 3 terms. So we can go ahead and set down our 2 empty pairs of parentheses. Now first times first is q squared, so that means I'm going to need to have q times q. The last term is negative, so that's telling me the signs in the parentheses here need to be different. And last times last is 3m squared. So the only pair of numbers I can multiply together to make 3 is 1 times 3. So I'm going to have 3m times 1m in these parentheses in order to get the 3m squared. Now notice that we need the middle term to add up to a negative number. So that means we need to put the larger coefficient with the negative sign. So I'm going to put 3m here and 1m here. And notice I didn't even bother to write the 1. Okay, now let's check our middle term. Outer times outer is going to be negative 3qm. Inner times inner is going to be positive 1qm. Negative 3qm plus 1qm is negative 2qm. And that's a match for our middle term, so that tells us that this factoring is correct. Now here's a practice problem for you to try, so pause the video and try it on your own. Now I'm going to go through it with you. So here we have x squared minus 6xy plus 8y squared. Notice that nothing is common to all 3 terms besides 1. So we can go ahead and set down our 2 empty pairs of parentheses. Now first times first is x squared, so that's going to need to be x times x. Last times last made a positive term, so that tells me that these signs in the parentheses will both be the same. They're both going to have to be the same as the middle term, so I'm going to need 2 minus signs here. And then the last term is 8y squared. So the only factors for 8 are either 1 times 8 or 2 times 4. But to take care of this y squared, we'll need each of our factors to contain a y. So we're either going to need to put 1y times 8y in our parentheses, or we're going to need to put 2y times 4y. Now remember, you want your middle term coefficient to be negative 6. So let's go ahead and use the 2y and the 4y. And since both of these have minus signs, it won't matter which one we put in which binomial. Now let's go ahead and check our middle term. So outer times outer is going to be negative 4y times x. So I'm just going to write minus 4xy. Inner times inner is going to be negative 2y times x. So I'm going to write minus 2xy. Then outer plus inner is going to be negative 4xy minus 2xy, which adds up to negative 6xy, which is what we wanted. And so this factoring is correct. Now we're ready to look at some trinomials that do contain a GCF. And notice I've made a habit all through this video of making sure that the first thing we do when we look at a trinomial is determine if it has a GCF. Up till now, the answer every time has been no. But now we're going to see some examples where the answer is yes, and I'm going to show you what to do about that. So before you begin to factor a trinomial into two binomials, always check for a GCF. If there is a GCF, be sure that you factor that out first. You're going to have to do it at some point, so you may as well make the problem easier on yourself by doing it first. Then, once you get the GCF factored out and you get ready to start breaking down your trinomial into two binomials, keep that GCF in front of the binomials. It is part of the answer. When you factor, you're saying that all of these things multiplied together will go back and make the expression in the original problem. If you throw away the GCF, that won't be true. So make sure you keep the GCF. Now, sometimes it's possible to factor the trinomial without factoring the GCF out first. But you're not going to get full credit for your work if you don't factor it out of the final answer. So it's easiest to factor the GCF out first. I promise you, this will be a habit that you will be glad you have. So here's example 7. We're going to go through this together. Notice the instructions say factor completely. A lot of times the word completely is a clue that you're going to need to do more than one thing to get the expression completely factored. So be on the lookout for that. Now here we have 4x to the 5th minus 28x to the 4th plus 40x to the 3rd. It probably freaks you out a little bit that you see x to the 5th here. And it should, because every example we've done so far has been x to the 2nd. In fact, we really don't know how to do these if we can't start with an x squared. So the fact that you see an exponent of 5 here, if that alarms you, just let that be a signal to you that, hey, I better hope for a GCF so that I can whittle this down to a problem I know how to work. And sure enough, if you look at these coefficients, we have 4 and 28 and 40. Now notice that 4 goes into all of these numbers. And if you look at the x powers, x is common to all three terms, so we should include x to the 3rd as part of our GCF. So our GCF is going to need to be 4x to the 3rd. And now we need to get a look at the trinomial that's left when we pull out the x to the 3rd. So what would we have to multiply by 4x to the 3rd to get this term? 4x to the 3rd times x squared would make that term. Then we need a minus. 4x to the 3rd times 7x will make this middle term. Then we need a plus. 4x to the 3rd times 10 will make this last term. So you see here we have our GCF in the front and our trinomial. It is very important that you write down this trinomial because it's very difficult to factor something that's just in your head. Do not skip this step of writing down this trinomial. So now let's go ahead and break this trinomial down into two binomials. So we're going to keep our GCF in front and we're going to break this trinomial down into two binomials. And see, now we're back on solid ground. First times first is x squared, so that's going to need to be x times x. Last times last is positive, so that tells me these signs need to be the same, and they're both going to need to be the same as this middle term, so I'm going to have two minus signs. And then my choices for 10 are either 1 times 10 or 2 times 5. So looking at my middle term, I think I'll have better luck with the 2 and the 5. So I'm going to put the 2 and the 5 in here, and now I'm just going to check my middle term. Outer times outer would make minus 5x. Inner times inner would make minus 2x. Together they add up to minus 7x, which is what we needed them to add up to. Because remember, we're factoring this trinomial that we got after we factored out the GCF. We are not working on this trinomial because we've already taken this big trinomial apart into these two smaller pieces. And when we factor the trinomial, we're taking this trinomial apart into two even smaller pieces. So I make sure that the middle term matches the middle term that I'm working on, and it does. And so that tells me that this factoring is correct. If you wanted to check your work, you could just FOIL these two back together to get back to this step, and then distribute 4x to the third to get back to the original expression. And now let's look at part B. Here we have negative 3y to the 8th minus 18y to the 7th plus 21y to the 6th. So you see this big exponent on the first term of our trinomial, and you really want that to be a 2. And the other thing is that our first term is negative, and we really would like for that first term to be positive because every one we've worked on so far has had a positive first term. So what we want to do here is definitely factor out the GCF, but let's make sure we factor out a negative GCF. So for sure the GCF is negative, but now let's ask ourselves what goes into 3 and 18 and 21. Of course 3 goes into all three numbers. Now, is y common to all three terms? Yes. And so y to the 6th will need to be part of our GCF. Now let's go ahead and figure out the trinomial inside the parentheses. So negative 3y to the 6th times y squared is what we need to make that first term. Negative 3y to the 6th times positive 6y is what we need to make this second term. Notice negative 3 times positive 6 makes negative 18, and y to the 6th times y makes y to the 7th. Okay, now negative 3 times negative 7 is going to make positive 21, and this term does not need any y power because negative 3y to the 6th times negative 7 will make positive 21y to the 6th. Okay, now we have a trinomial here that can be factored into two binomials. So we'll keep our GCF in the front, and we'll break this trinomial down into two binomials. First times first is going to be y times y. The last term is negative, so that tells me these signs need to be different. I'll put down a plus and a minus. And our last term is 7, so really for last times last, our only choice of factors is 7 times 1. But we want to arrange those factors so that the middle term will add up to positive 6y. So let's put the 7 with the plus sign and the 1 with the minus sign. And now let's just verify that outer times outer plus inner times inner would add up to positive 6y. That's a check. And so we know that this factoring is correct for this trinomial. And that's it. Now if you're feeling a little overwhelmed in this section, that is totally normal. This skill is definitely necessary to success in later algebra courses, but it's not something that comes naturally to everybody. You're going to have to work on it and develop this skill, and it is something that you can do. If you can put together a jigsaw puzzle, you can do this, but you just need to practice. Okay, so definitely set aside some time and work on it and ask your instructor questions all you need to. But the more you practice, you'll see the better you'll get at it. Good luck.